Welcome back. In this video, we are going to start with the next unit, and this is about graph. In your school days and your PU level, you might have studied different kinds of graphs, and we are going to see what this graph can do with our data structures. So we are going to see what is the definition for this, and moreover, we are going to see what are the different terminologies we use to represent a graph. And normally we do represent a graph using two different techniques. One is a matrix, other one is adjacency list representation. So all the things we are going to see in detail in the coming slide. So let us see the definition for a graph. There is no particular definition for a graph. Different textbooks say different uh, definition for this. So graph can be viewed as an abstract data structure. Some textbook says it's a collection of vertices and edges. Some other this says it's a generalized form of a tree. If you take a normal tree, there exists a single relationship between a child and parent. There's only one relationship. But a graph can be viewed as a generalization of tree structure where there can be a complex relationship between any two nodes. So let us see what are the terminologies we use to represent a graph. So as I told, it's a collection of vertices and edges. So we put in pair. So V stands for vertices and the letter E normally represent edges. So edges is defined by pair of vertices, and vertices is also known as nodes. So normally the vertices are represented with a circle and edges are represented with a line which connects between the circles. So if you look at the diagram on the screen, where you can find the vertices as A, B, C, and D, and the edges are AB, AC, BD, CD, and AD. So we have got a graph with 5 vertices and 5 edges. So let us see what are the classification of graphs. So there are several classifications of graph. Let us see what are those. The first one is weighted or unweighted. Next is directed and undirected. Third one is cyclic and acyclic, and fourth one is multigraph. So let us see the first one, which is weighted and unweighted. So weighted graph is a graph which has got weights for its edges. Already we have seen what is an edge. So every edge has got its own weight. So this kind of graphs are known as weighted graph. So normally we use this kind of graph to represent a traversing, which can be traversing cost or traversing, time for that. For example, we can say like the distance between two cities can be represented using a weighted graph. So other one is unweighted. So in unweighted graph, there is no weight for the edges. So edges simply make a connection between the nodes. For example, course prerequisites. Think that you are studying different courses in the second year, which does not have any connection with your previous year subject. So this is an example. So next is directed and undirected. So as the name says, so directed graph, so having a direction. Undirected graph does not have a direction. So undirected graph can be traverse in either direction. There is no direction for that. So we can move in either direction. If it is directed one, only in a specified direction we can traverse. So you can see a undirected graph on the diagram. So where there is a path between A to B, at the same time from B to A there is a path. We can move A to B as well as B to A. So if you take the edges is unordered pairs. So which means we can write it as AB or BA, which does not make any difference. If it is a directed graph, so there is a particular direction for every arrow mark, or edges are directed. Edge can only be traverse in the direction of arrows, and edges is an ordered pair, not like undirected graph. If it is an undirected graph, it's an unordered pair, but here it is ordered pair. So you can see that there is a arrow from A to B. So you have to write it as A to B, and A to B is not same as B to A. I mean to say that A comma B is not same as B comma A, because there is no path from B to A. Same way we have A to C, but C to A there is no path. A to D there is a path. B to C there is no path, and D to C there is a path. So look at the edges. Edges is an ordered pair. So we can see that A comma B is not same as B comma A. They are not the same edges. So next is the degree of a knot. So degree says the number of edges incident on it. So if you look at the diagram, you can find B. At B, there are two edges which is incident on it. So we can say that the degree of B is 2, and even if you take C, C has got degree as 2. And if you take D, there are three edges which is incident on that. So we can say that D has got degree 3, even A has got degree 3. So I can say, like, B has got even degrees, B and C has got even degrees, and A and D has got odd degrees. And there is something called in degree, number of edges pointing to a knot, and out degree means number of edges pointing from a knot. So this normally happens with directed graph, because in undirected graph there is no direction, so there is nothing called in degree and out degree. So next is path. So path is nothing but a sequence of vertices in which each pair of successive vertices is connected by an edge. Each pair of successive vertices is connected by an edge. So cycle is nothing but a path starts and ends on a same vertex. If you look at the diagram A, B, C, D, so there is a path from A to B, B to D, and D to A. So we can say that it's a cycle. Simple path is nothing but a path does not cross itself, which will never cross itself. So length is nothing but, or length of a path is nothing but number of edges in a path. So if you take the path from A to D in the given diagram, we can say that the length of the path is going to be 2, because we have to come across two edges. One is A to B and other one is B to D.